I'll present a paper that's called the Web of Things, a survey, which is basically, it is a survey. It kind of collects information about different fields within the WOT, and it kind of presents it and summarize and compare a bit. And yeah, I'll just jump into the goal of the paper. It says that to elaborate the architecture, describe key enabling technology, show some pioneer open platform and prototypes, carefully summarize summarization of current state, systematic comparison to provide insight in the Web of Things evolution. And it kind of lives up to the goals, I would say. Maybe not the systematic comparison, but it's kind of comparisons throughout the paper. First, it starts to discuss the interoperability in Web of Things. It kind of talks about three different solutions or platforms. The first is the universal plug and play, which was which is a suite of networking protocols, mainly made for personal networks devices to discover each other's presence, to establish connections on the network, onto the network. And it has some drawbacks. It's no authentication. It's not strictly standardized, and inapplicable to some resource-constrained devices. And then we have JXTA technology, which is proposed as a solution for peer-to-peer application design, enabling interconnections of heterogeneous devices into a network. Unfortunately, it has not been standardized and has not been well accepted for embedded devices in industry either. And then we have the web, which in the paper they say that it's the best solution of all the above, and it's more flexible, scalable, open, and easy in terms of easiness, customization, security, and stuff like that. And then they discuss some architecture. First, they discuss, they talk about direct integration, which is basically the smart things with which is IP enabled and have embedded web servers that can be directly connected to the web. And then they talk about indirect integration, which is objects that's is S2 resource constrained to be able to contain embed web servers, which maybe might then talk to a gateway through Bluetooth, which is further connected. And then they have the discussion between the web service and REST. And in most of the papers I've seen throughout this course, they always propose that REST is the best architecture for Web of Things, as it's more lightweight and because of loose coupling, it's stateless and more flexible. Even though they say that web services has it's useful in some cases, and they will probably coexist further, but they always tend to say that REST is better because of mostly because of because it's lightweight and many of the objects are resource constrained. Yeah, and then they talk about some enabling technologies. The 6LoWPAN is IP is acronym for IP version 6 over low power wireless personal area network. This is kind of like a compression mechanism that makes it able for and it's very good for to communicate between the low constrained or resource constrained objects. And it usually adopts low power radio communication protocols like IEEE. And it has some features like header compression, which is kind of necessary because, for example, IEEE has a maximum transmission unit size of a maximum of 128 bytes, while IP version 6 packets can be as large as 1280 bytes, which makes both the header compression and the packet fragmentation necessarily to like compromise for this mismatch. It also has edge routing to connect the personal area networks to the internet. And then we have CoAP, which stands for Constrained Application Protocol, which is based on UDP. It's more viewed as complementary to HTTP, and it targets resource-constrained networks such as wireless sensor networks. And it's designed for applications such as smart energy, smart homes, as well as other machine-to-machine applications. Yeah, it has some features. It's based on UDP, and while HTTP is based on TCP because of the high overhead introduced by TCP mechanisms, such as flow control, which is not suitable to resource-constrained devices. It said CoAP is designed to lower the header overhead and parsing complexity in order to be applied to resource-constrained devices. It supports asynchronous transaction, which is a key requirement for machine-to-machine communication. It supports URI and built-in resource discovery, and it supports a built-in subscribe notify push model as well. And then we have the embedded web server, which in the recent years has been there've been a lot of tests, and they have been trying to implement it with being as or being much more less resource constrained. And I read an example of in the paper where they mentioned that they implemented a web server on sensor nodes using 15.8 kilobytes and less than 1 kilobyte of RAM, which is kind of that's
small.
Yeah, exactly. And then they mention two types of mashups, which we're kind of familiar with already. This first is the physical virtual mashup, where you take, like, for example, you may have some sensor nodes spread out, for example, in Gjøvik, and then you can mash that up with a Google map, and then you can see like the temperatures in different places in Gjøvik. And then you have the physical mashup, where you might want to mash up two different smart things from two different manufacturers into a system. And then they mention some open platforms and prototypes. These are kind of many. I'll just read through them because I don't remember about information about all of them. SenseWeb, it offers a platform mainly targeting for participatory sensing. A sensor gateway is used by sensors as a uniform interface to share sensor data. SOAP-based APIs are used to allow developing sensing application with shared sensing resources. Then you have SensorBase, uses a relational database table as its data abstraction, and SQL-centric APIs. It is a web application that not only provides the user with the functionality of a traditional database management system, but also runs under the notion of Web 2.0 data experience with responsive user interface design and RSS data feed techniques. Sensorpedia is a web-based application enable people to share, find, and use sensor data online. It provides users a Google Maps interface where users can search and explore published sensor data. Sensor Network is a web-based infrastructure for storing, sharing, searching, visualizing, and analyzing data from heterogeneous devices. PackHub provides APIs entirely based on HTTP request and conforms to the design principle of REST. The physical to virtual APIs provides by PackHub enable quick and easy development of applications that add the value to network object and environments. Vasquez, I'm not sure how you pronounce that. Vasquez, yeah, which is a flexible architecture for implementing monitoring application based on wireless sensor networks. They propose a 3-layer architecture: sensor layer, coordination layer, and supervision layer, which enables intelligence, distribution, and decision at different levels. Tiny REST. They introduce a new HTTP method, subscribe, which enables clients to register their interest to specific sensor services with various personalized parameters depending on each client's needs. The Pico REST, an access protocol with the goal of bringing the web simplicity and holistic view on data and services to pervasive systems. In a REST style, PREST emphasizes abstraction of data and service as resources. Energy visible, software that can easily use to monitor power consumption of devices connected to Bluetooth, enable smart plug like plugs. The software retrieves all plugs in the environment through a smart gateway using REST APIs and exposes their functionalities and via visualized web page. Then they talk about some open issues in the current state of Web of Things. The first is the heterogeneity of the devices and scalability. As I mentioned, they're looking for like a platform, and now like they think that the web is the best choice. But there's so many different devices out there from different manufacturers, which all they like the best scenario would be able to like connect all of them, and you can make all kinds of applications. But that's kind of the biggest issues now. There's too many standards and protocols going around, and like there's not this universal platform. Yeah, and then you have the privacy and security. Obviously, there's a lot of data that's being tracked and stored and handled all the way from like smart homes to health applications and stuff like that, and they need to find a way to handle the security. And then they talk about search and discovery. There's when you're connecting a lot of these objects and smart things, they need to be able to identify themselves and connect to the system. And there's a couple of, they have a pull and the push method, where like you can either where you have the push method where the sensor kind of pushes to the browser, and that way you can like be able to connect, but that lacks the scalability. And then you have the pull approach, where the search engine kind of sends out a request and then demands an answer, which is it's scalable, but it has less accuracy and is more time limited. And then they talk about the ambient intelligence, which is basically where they want the sensors to like recognize emergency situation and then fire an alarm accordingly. And one of the problems here, I have in my notes, I don't remember exactly. Comes from the heterogeneity and availability of smart things that provide user. What I've been writing. Yeah. Okay. So I'm not really sure what I've been doing here. Let's see. Been kind of stressed lately. Yeah. Yeah, I'm not really sure. Sorry. Yeah. Okay. So in the conclusion, they kind of just say that it's like the big new possibility and the challenge of the internet, and it has a great future and all that stuff. And since it's a survey, it's more like they just kind of comes with an overview of what they have mentioned in the paper. They just go over the different chapters and they just mention like a bit about each of the short about all of the topics that they have been talking about. Yeah. Oh, I'm sorry about that. It might be a very confusing presentation.
Do you take questions?
No. Yeah, of course. I'll take. If you ask me the right one, I'll take it. Sure.
I was just partially reading the paper while we were presenting it, and see that the paper is from September 2011, and like the Web of Things has really matured since then and changed a lot. Do you still see the paper as really relevant?
To be honest, I saw that as well, but I've been reading a lot of papers on it lately, and I feel like it's pretty much they have the same train of thoughts that the new papers have, and they have many of the same arguments. And I mean, I guess some of the technologies here have kind of been. I have not read much about like this 6LoWPAN, but that might be because I haven't been diving much into it, or if
it's kind of outside the web as well, because this is low-level transfer protocol. So
yeah.
This is how you connect the devices to the network. So
that might be
the co-op is more relevant because that's one level up. But even that is kind of providing the web infrastructure. I mean, the same as HTTP. You won't find much research on HTTP in web because it's part of the web basic infrastructure protocol, and the co-op is the same. So these two protocols are kind of just underlying and enabling the devices to to communicate on the web. So you won't see much of these ones. So it's more, but I think I agree with the here is that the areas of the challenge areas are pretty much the same. So this is a good paper in saying what the challenge areas are, and the actual status within each area has moved quite a lot since the beginning. So that's part of what needs to be studied in one or several of these sub areas. What is the status right now? But
so there hasn't been much of development and improvement in terms of Web of Things since 2011, let's say.
I would say that this paper kind of I'm not sure if it's because they're too general in the way of discussing the different topics, but the way I see it's if this had like been, let's say they just set the figure to 2014, I'm not sure I would like seem different or like so this, yeah.
So if you go up to the slide where you have the challenge areas, if you go slightly forward.
Oh yeah, yeah.
I mean, these are still open issues, but if you go to one of them, you will see that the things have changed. You know more about how to deal with security and privacy, but it's not the sole problem still. And there are, especially when you would like to have, I mean, allowing access to data, but in a way that the user is in control. And that is still a hot research area in biometrics or in privacy in general, and that is not completely solved, but things have changed on other platforms since the paper was written. But I think it's good in terms of describing the field and what are the major areas to be worked on. But it's, as far as I know, there is nothing really new, no really new challenges come up, and these aren't solved. So that's why it's still these are still relevant as a subdivision of the field. Not to say what the status is within these areas, but these are still the areas that there are quite a lot of work going on.
Did you hear about the botnet that was it took part in what is considered as the largest denial of service attack so long, and it was made up of IoT devices?
What? No.
No, there was this attack towards a security expert called Brian Curbs. He's a security journalist. He had written some articles on some people that solved denial of services on the internet, and they got mad at him, and they designed a botnet using routers and web cameras. And they used like exploits in those devices because those devices never get updated because the users doesn't care about them. And then they got connected, and they, I think it was either it was 500 gigabit or I think it was 500 terabits per second or 620 or something crazy like that.
Yeah, that's pretty
insane.
An interesting fun fact: the source code has been leaked online now.
Yes,
You want to
I
build
just
it
saw
yourself.
the article this morning.
Yeah.
That's insane.
Do that for a master and you'll get an A.
Yeah, I guess. Sounds like a good idea.
But I think for us as a group, I think the paper is still quite valid, and it kind of sets the scenes, it sets some of the challenge areas. For Lars, he needs to go much deeper
Yeah.
and warm or several of these sub areas. Might be too much to cover it all.
Yeah, it is.
But, one or two of these sub areas.
But like currently, that's the only paper on Web of Things listed online, so that should be more or less
Yes.
what we should know about.
Exactly.
Yeah, and it's pretty much, it talks about many of the same areas that the last paper had. So it's pretty, I would say it's pretty similar content-wise.
Yeah, I mean the core papers. The idea of the core papers is to give you kind of a broader perspective, and you can't be both deep and broad at the same time. So that's why this is probably one of the more suited papers in the core. And so for the other papers, don't worry so much about the details, because it's really about providing a little bit of breadth into the general web tech understanding, and the depth will be in your selected topic and specialization.
So as long as we get a good understanding about the topic, we can also find other sources that they explain it like briefly or something. It doesn't have to be that specific paper.
Sure. Yeah, it's about understanding what's happening in not the whole web tech field, in the web tech as we covered here. I mean, with the specializations you cover. So it's not other parts of web, but within this, we expect you to have that kind of understanding of the web tech field more than just your narrow area, but in that narrow area, much deeper than in the rest. Okay, so that completes the paper session. Yes, the rabbit is here. So let's do now. Take around the table and see where you are at in terms of the projects and in terms of your specialization, where you are aiming, and first status, and anything interesting you want to share, anything you would like feedback, so we get kind of an idea, because we're not gonna, next week there won't be such a seminar because we have the exam on Wednesday, so, and you have submitted the reports on Sunday, so there isn't much need to, there's no more stuff to go through, you need to just read and prepare for the exam. So now what I want to see here is that in the course of your in-depth projects, is anything you found, anything you'd like to share, anything you'd like to discuss with us since you started going into your area. So, and of course, it's not something that we will spend a lot of time during the exam to talk about, but it's interesting still, and since you have been diving into this in more depth, you hope that you have something to share that might be useful and interesting for everyone to know about. Somebody,
Yeah.
first.
So I have about microservices, as you all may know, and much of the issues around microservices today is that there's a lot of discussion going on in the field regarding what should be done, and for example, how tiny should a microservice be, because there's drawbacks. If you keep a microservice too small, there becomes a lot of overhead in terms of network communication and management of the service, and if you keep it too large, it kind of diverges away from the microservice pattern, and it becomes too coarse-grained, and then it becomes sort of its own monolith in the system. And this is just one of the many things there's a lot of discussion around. And what I found particularly interesting with the microservice pattern is that there's no clear definition on the actual pattern itself, which means that many people have their own interpretation of the architecture. And I think that's also a strength in the pattern as well, since that doesn't constrain yourself from designing the system that you want, compared with service-oriented architecture, where you have very clear standards on what to do where, and what kind of technologies you should use, and how different services should communicate with each other. And one of the challenges, especially with service-oriented architecture, is that it becomes very large in a sense, and in many cases you don't need all of those large hierarchies and advanced abstractions that comes out from service-oriented architecture, whereas with microservices, they don't even describe any of those kind of abstractions that service-oriented architecture has. That being said, microservices isn't the solution for every single system. There are still applications that can be better implemented with service-oriented architecture compared with microservices. For example, if you have a very complex organization with many business rules, many different heterogeneous services which require different kinds of integration, SOA may still be a better option than microservices, because microservices, they favor more or less heterogeneous communication environment. For example, everything should go over HTTP or some similar lightweight protocol, and they don't want to use SOAP because that's very heavyweight and it creates highly coupling between the services. And additionally, another thing that's being discussed a lot is whether service-oriented architecture is actually a new pattern on it in itself, since many people argue that SOA is microservices, and that microservices is kind of the service-oriented architecture that the industry has been pushing on the last 5-6 years. And there's a lot of debate going on in the field, and people have different interpretation of the different fundamentals both behind service-oriented architecture and microservices, and that creates kind of a huge discussion around those things. And, yeah.
We had a small chat about the fact that when you use the web infrastructure, and that can be for web things, or it could be for microservices, you use protocols that were originally designed for a different purpose. I mean, HTTP was originally designed for giving HTML documents to people, and kind of the underlying transaction model is that somebody is looking at through pages. And as the things came up, it said that the protocol is HTTP is too heavy for some of the devices, so you might go for a co-op instead, which is a reduced set. And then it's kind of the same thinking here, or you may think in the same way here, is that when you have applications communicating, then some of the web protocols that are designed for use in machine communication may not be optimal. So you may want to, there's a room for optimizing some of the protocols, and use the same philosophy, have REST, and the upper layer have REST, but rather than using HTTP, you may have more optimized protocols underneath. So these are kind of Internet of Things and microservices may share some of the ideas and some thoughts there on the underlying infrastructure.
Because in the microservice architecture, your system consists of different services, and those can be considered as nodes, and that's the exact same problem as you have in IoT.
And also the whole mashup idea. I mean, you can also think of designing or using microservices through a mashup type of interface, the same way as you have when you have lots of sensors, you like to mash up the data from the sensors. So they are very different, at the same time they share some issues and some interesting, not problems, but I guess opportunities for improving. Okay, great.
Right, so would say that this is more or less like fun facts. But right, interesting findings. But one really cool finding is that the creator of Bitcoin, which goes by a pseudonym, so nobody really knows who he is, he might be Australian and everything, like he ran the network by himself in the beginning. So he generated a lot of coin, like some say, like with the current exchange rate, he might have billions in US dollars if he exchanges everything with the current rate. But he hasn't moved his money at all, apparently. Like, since all the transaction data is publicly available, you can see that his Bitcoins are still there. Hasn't used them at all. But then again, some people theorize that if he actually like takes out all his money, that's like the creator saying like this is not viable, and like that's a sign of him abandoning it, and everybody will abandon it as well. So it might be in a tight situation there. We can't really use his money.
Like the stock market.
Yeah. Like one of the biggest problems of Bitcoins currently is like if a large portion of people sell off their Bitcoins, suddenly it just crashes. Like it's really unstable currently. And another cool thing I found while researching this is like they want to make a web payment framework and everything, but actually kind of a large problem is that there's a lot of people still in the world that doesn't have a bank account, that doesn't have a credit card, doesn't have a card anyway to pay online. And like if you look at, for example, Germany, in addition, they have like crazy love for cash. They don't like using cards. I think my data is like somewhere between 60 and 70% of all transactions is in cash in Germany. And that reflected while I was visiting Germany. Like I went to McDonald's and didn't have a bank terminal. It's that bad. And like making an online payment framework for them is kind of useless. But then again, most of them, like if they actually need to order something, let's say from Amazon, they usually have a credit card somewhere, so they can actually do it. Just fun to see how many people in such a modern country still use cash to this day, compared to Norway and everything. A bit sad thing is that like most of you probably know about like in the United States, they really like checks. Like using checks all the time. So of course, when the online world of payment solutions came along, they invented electronic checks as well. And a lot of the research I've been reading about really pushes for that kind of technology, which is like backwards as hell. But a lot of people want to do it. But at least checks are on the way out. Like for them. People around our age, at least in the United States, seem to stop using it, not using it anymore.
Well, I don't know. I was just in the States, and the family I visited, the middle son, he's now just started his college. He did all the payment with check still, but he did use his camera though. So he just took a picture of the front and the back of the signed check, and then that's how he communicated with the bank. So checks just
why?
I have no clue. Well, it's why are they still using inches and Fahrenheit? Still, it's convenience. It's convenience to change the culture. It takes all the time and efforts. So if they don't see the strong benefits, because they can still use the checks, so they used to use the checks. So.
Yeah, I looked a bit into sources, and some people theorize that one of the reasons they're using checks is because they have so many different banks in America that a common system between them is not to be found, and there's a lot of fees using other systems, and checks, as far as I know, have a really low fee there, so there might be a benefit. And there's the sort of, there's a safety mechanism. Like if you use a check, it takes a few days before it's withdrawn from your account, so you have a few days to sort of fill up your bank account or remove the money if you don't want to pay. So you have sort of somewhat more control, you can say. I don't know. But another cool thing I found was that in America they have recently gotten cards with a chip on, so that's really cool. But they're still not using PIN codes at all. Like for large transactions maybe, but like going to the supermarket, usually you don't need a PIN at all.
I was there in the summer for 2 weeks. I think I entered PIN codes twice.
Yeah.
The rest you just swipe the card and not even signing. You just swipe the card and
Just for amount like below, or is it like a limited amount?
Below 10,000 or something.
Whoa.
It's crazy. Like they don't have security there, but they have a system called chargeback, where like if someone uses your card for like stealing some of your money, or use it, like I take your card and go to the shop and buy with it, you can initiate a chargeback where you get sort of a refund, and the shop has to pay everything, and it's just a horrible system. Like if you use Braintree, which is an online payment framework where you can like integrate with credit cards and everything, like if a customer chargebacks, you just instantly get charged $10, no matter what happens. So it's kind of a broken system. But then again, like if we go to France, there are some banks that recently started having constantly regenerated security codes for credit cards. Like on the back of your credit card, when you buy, there's three numbers on the back you enter in. But those are static on the card. But some French banks have actually included like electronic display there that switches the numbers each hour. So more or less the last codes was invalid. That's actually kind of secure, but it's the same as Value did back in the day, if anyone knows about Value. So like turning your phone into actual credit card, that was really big. You needed an app, you need a special phone, and you need a special SIM card. But those guys also had regeneration of the security codes.
Before we move on, maybe just a couple of words about it. We found a couple of alternatives to Bitcoin. I mean, Dogecoin, Litecoin. Maybe say a little bit about.
Yeah, that's the next thing I was thinking about that. Like Bitcoin is the huge cryptocurrency security, and it's more or less the first. But there are some alternatives. I just need to find the place. Because like the code is publicly available, so anyone can in theory make their own cryptocurrency, which will be really fun as a side project if anyone wants to do that. But then again, like I talked about earlier, if you hold less than 51% of the power in the system, it's really easy for someone else to just come in and suck it up for you. But anyway, there's some alternatives. Like we have Litecoin, which is more or less the second best alternative, as a currency at least, which has really low, like if you want to exchange, let's say 1,000 Litecoins, you're getting just a few dollars. Compared to Bitcoin, one Bitcoin is $600. There's not really a competition. But there are some alternatives, and like we have Dogecoin, which is based on a meme. It's just a joke currency, which actually gained a lot of traction, like Litecoin. But then again, there are no alternatives compared to Bitcoin at least. But who knows? Like, for example, Litecoin supports 4 times more transactions a second and 4 times faster transactions, but more overhead, so it's no problem. But then there is something more interesting called Ethereum, if someone has heard about that. Some people say that might be the largest thing ever to happen, but we only time will see. It's more or less taking the blockchain and evolving it so that you can code in it. It runs as a sort of a virtual machine, decentralized virtual machine, where you can have applications in it. Like one example is Augur, which allows you to buy shares in a system and then to put those shares towards predictions of the future, like who's going to be the next president. currently it's 67% on Hillary Clinton and 30-something% on Donald Trump. And like, if it turns out that you voted correctly, you get twice the money. If you voted incorrectly, you lose everything. And that's one example of how you can utilize the system. And another example is like you can actually make a decentralized version of Uber with no centralized authority working at all, because you can code into the system smart contracts based on criteria like did you pick up the person, did they arrive safely at the end? Okay, then the payment is authorized to the driver unless something goes wrong, and then the payment goes back to the customer, for example. Still really early in development, but like Simon is crazy about it, and it's really interesting if someone wants to get it fully open source and everything. And if it turns out as they think, this might be one of the largest things ever to happen inside cryptocurrencies, and maybe the web can make everything in this. Yes. I don't know if you know about it, but VC3, like the guys who create HTML5 protocol and everything, they actually started working on a web payment framework, like just as I started all this paper. It was perfect timing. Like it's really early in development, but if this comes to fruition, like in a few years, we're going to see a payment framework appear if we're really lucky. But it's more or less not like new currencies and everything. It's more like just tying everything together so it's easy for developers to add support to everything without using a third-party app that like requires insane fees. Like just for comparison for the fees, if you use BrainG, which is alternative I looked into, and PayPal, it's almost 3% of the entire transaction value plus additional fixed fee of like $0.3 per transactions. Like that kills small amounts instantly since it's a fixed fee, and 3% is actually kind of high. Like compared to iSettle, which is like a physical terminal made in Sweden by a new company there, like they have 1%. So there's a lot of money to be gained by using the right system. Well, there's a lot of stuff there, but I don't know if anything else is interesting. All the way back in 1997, this actually was attempted also, but it failed horribly. I don't know, is there anything more you remember that you want me to pull out?
No, I think that's good.
So any questions about currencies, the future, cryptocurrencies, Ethereum, blockchain?
Do you know it all?
Yes, like in this damn delivery, I have now, not to flash it, 52 references. Like it's just out of control. There's so much information.
I believe Rune is on the quality check everyone. You know it?
Yeah. And like I said earlier, Bitcoin is not a real alternative to using your credit cards. It's mostly for storing a value.
What you could say about the references is that they aren't all scientific references. Very few more.
Oh, no. Like each time they're saying, for example, this one payment solution is Google Wallet. I reference Google Wallet, so there's some extra there. I think the scientific papers are like 15, 20 or something.
Okay. Yeah. So my topic is flipped classroom, doing a state of art in this topic. So as we already know, like kind of all the process, everything during the past 20, 30 years changed, except the educational system, like more specifically in high school, for example, is the same as 100 years or 200 years ago. It's more teacher-centered approach than student-centered approach. And the flipped classroom tries to change that, and I did a lot of reading, and there is a lot of research in flipped classroom, especially in high school and in science, technology, and mathematics courses. The kind of 80% of the papers that I have, they are more focused on the student perceptions and benefits that the student take from the flipped classroom, which compared with like if we compare the papers that are focused on the student performance, there is a lack of research on that field, which I would say it's very important to more focus on the student performance than the student perception during the flipped classroom. And so where I decided to focus more on the use cases of the flipped classroom and the learning styles, the models. There are different models of the flipped classroom and some taxonomies, and also doing a summary of the student perceptions and benefits from the research that I have. And I'm trying to find other papers related to the effectiveness and performance, because there is a serious lack of research on that.
But it is a very hard thing, though. How do you measure the actual learning outcome? It is a very, very hard problem.
Yeah, there are like kind of learning. Yeah, there are two papers that focus on the learning outcomes, but still they are not very specific. And I will try to focus more on the challenges. Like all the research that I read have the empirical approach, and they kind of assess the challenges and the opportunities that the flipped classroom gives. And I will try to see the similarities, which are a lot in these papers, and I will try to see where are the disagreements on these papers. So yeah,
and if possible, it's also a good idea to look at what technology, how web would play a role in that flipped classroom, because it on one side is purely educational.
Yeah.
At the same time, it's also supportive technology will make a difference, and that's why this is kind of in
yeah, I was thinking to split to categorize the challenges into the technology based and user based approach. So I will try. And there are also, like, I have 3 papers or 4 that use Moodle and other learning management systems to flip the classroom. So I would mention the technology also. Okay.
So, like, the classroom is just doing it more online, like adding Moodle into it, and
it's not just adding Moodle, but it's changing the whole learning system. It's kind of more active learning than like just teacher-centered approach. So the student has more responsibility to learn on himself than it is like now in the high school, because in university it's most of them are applying this technology, not technology, but this approach.
Yeah.
So the idea is, rather than being introduced to a concept at school and then go home and do exercises, it's the flipped. So you prepare at home and you do exercises in the classroom with the teachers and fellow students or projects. So you actively work, but you try to learn and grasp all the concepts at home rather than being introduced in the classroom. And then when you are together with other students, you actually refine and reflect and use the knowledge rather than trying to grasp it.
Yeah, it's more based on the collaborative learning and problem-based learning.
So that's where I was thinking technology, both when students sit at home and try to learn it, just reading is not probably the best way to learn. And then at school, collaboration tools and tools to have them work jointly. And so that's why I think the lab technology comes into play here, is to help forming the environment, both when the students work home and when they are at school.
There's also a couple of research that classifies like high achievers and low achievers, how they perceive this flipped classroom. So there are some differences between them.
Absolutely.
Yeah.
Okay. Yeah. Well, for my specialization is in terms of recommender systems, like the general idea what recommender systems are all about, why they were initially introduced on the web, and but I will specifically try to look more into the part of user involvement and user control in the recommendation process. So why did recommender systems in the first place were introduced is because starting from the Web 2.0, people were faced with like a lot of information, so information overload, and a lot of user-generated data were taking place in the web. So people were just overwhelmed with information. Like you go to an online store and like they have let's say a lot of products that could be explored by the users, but so usually users do not have the time and effort to go into all the available products, and usually it's kind of hard to find what is interesting, what matches their tastes and preferences. So that's why recommender systems have been introduced in the first place. What is interesting about recommender system is that there are quite a lot of different types of those systems, and they're all so they all work based on whether you look into the content of products or items, and based on the content or description. Let's say for movies, for example, you look into the artists, the actors, or you look into the genre of the movie, or you look into the director, and based on those attributes, you try to recommend users certain movies that they would potentially like. So these are called content-based recommendation systems. But we also have collaborative recommender systems, which are mainly focused on trying to find users or items that are similar to the targeted user, or the user who is trying to the system is trying to recommend items to. We also have knowledge-based recommended systems, which basically get explicit information from the user, what they want, and so then using that information and a knowledge-based system, they try to fit in the recommendations to the user. We also have hybrid systems, which are systems that try to combine the strengths of different approaches, from the content-based and collaborative-based filtering. Another important fact is how user control and user interaction with the recommended system affects the user satisfaction in terms of recommended items. And many research studies have been conducted to find out how to find methods that could simplify the user interaction with the system, because usually behind the picture there are these really complex algorithms that work on trying to make the recommendations, and if you just expose that to the user, they're just going to get overwhelmed with that complexity and just scare them away. So that's why a lot of research has been done, and like trying to use visualizations, trying to simplify input, like asking users different questions that will afterwards contribute into the user, making the user profile, and trying to make as more accurate recommendations as possible. Some other interesting things that are related to recommender systems are, for example, novelty of recommendations. Novelty recommendations means, for example, how novel an item is, basically how unique, and yeah, authentic, or how, like, they're recommending something that the user didn't know about but still would like to explore. Another thing is also the serendipity of the items. This means like recommending something that the user would not expect to, like having unexpected recommendations, but still a recommendation that the user would probably like to explore. And also the diversity of recommendations, because usually a lot of recommendation systems try to recommend popular items, obvious items that the user would explore by themselves without the help of the recommended systems. However, the main idea and the validity of the recommender system is how diverse the recommendations are. So like not just recommending obvious items, but having a wide variety of different type of products that the user might like. Yeah, and there's also interesting to see how just accuracy of recommendations is not efficient. Is not sufficient for the user to be satisfied with the recommendation. So there are a lot of factors that play an important role or have a lot of impact in terms of user satisfaction with the recommender systems. Is, for example, the trust that the user has on the recommended items. Is also, as I said, diversity, novelty of recommendations, relevance, like just recommending items that are not relevant at all for the user taste or preference. It's not very accurate or efficient for the recommender. So, but basically, from the beginning, like the recommended systems have been around since 1980s for the first time, and throughout the reading, I saw that they defined the evolution of recommender systems in 3 waves. The first wave is like the more primitive way where recommended systems were used for scheduling and filtering emails and so on. And then afterwards, with the second wave, with the introduction of the social networks and emerging of online retail stores, the recommended systems played an important role in this part. But what is common for the first and second wave is that these recommender systems were more focused on increasing the business value for the companies, like trying to increase the product sales by just recommending items that the user would potentially purchase, and not having a more like concentrating more on what the user needs and satisfying the user needs. So the third wave, which we are currently on, is more based on the user perspective. Like, for example, we have now Siri, for example, is considered as a recommender system of its own, and it's more like a personalized recommender system that work on recommending different type of information, like, for example, on the quantified self, when you track your own activities, trying to recommend you a possible route that you might take, or recommending you different type of nutritions to consume during the day. Or it's just, so the third wave is more concentrated on helping the user rather than helping businesses improve their increase their value and increase their product purchases. So basically, my survey would It will start with an introduction of recommender systems in general. What are the problems faced? What are the different type of recommender systems? As I mentioned, collaborative, content-based, knowledge-based, hybrid, and then go into more detail and explore the idea of having user control into recommender systems, because at the end of the day, it's like exploring the user preferences, trying to target recommendations that are accurate, that increase the user satisfaction while browsing for certain products. So, yeah, any questions?
How much do you deal with the issue where, for example, sometimes people send me links to YouTube and sometimes the videos are not so good, and it's something that I would not like to see, and in some cases I get recommended videos on YouTube based on those videos I don't like.
Yeah.
So
yeah.
How often do you deal with that?
Yeah. So that's why it's important to have a little bit of user control in terms of modifying your user profile, because YouTube obviously Google has already constructed your user profile, and like in some cases when you just browse a different type of, let's say, video, the recommender system would pick a characteristics which will afterwards use to recommend other videos that are related to that, but then you don't have a lot of control. For example, let's say, okay, you're getting some videos recommended that you would not like to see, but then you cannot just go on YouTube and try to modify your profile, or just see why you're getting that type of recommendation, those type of videos. So the idea is for the user to have this possibility, to have this opportunity to just go and remove something or modify something in the recommended system, so that you don't get inaccurate recommendations. But this depends a lot on the user's interest on the field, on the domain, but it also depends on how the interface, how the system makes it possible for you to interact, modify the recommender system, because if it's too complex, you might just crash the whole system and just get inaccurate recommendations. So this is why it's important for the user to have some control into recommendations in order to adjust and to better fit the recommendation for its own needs. And YouTube, for example, does not have that. You just have to. They have that.
Yeah. You just click on the three dots above each other and you click not interested. You can select it out.
Absolutely.
Get a survey.
Okay.
I think it might be a historical reason, because in the beginning they were hoping that users would say, oh, this was relevant, this is not relevant, this is relevant, this is not relevant, but users don't generally want to spend all the time giving feedback to systems. So in general, if you're really upset or you're really happy, you may fill it out, but in general you don't. So the feedback you get is not representative for what you like and dislike at that point. But these things may change. So I mean, the more users are used to likes on Facebook, and then maybe also some other dislikes and some other icons on Facebook, then it might be easier to introduce the same thing in other systems. So this is a very dynamic area.
Yeah, but that, if you just say, okay, I would not want this, that is just for that specific video. So I don't know. I haven't read about how YouTube recommended system works, but it's probably your profile already has this, let's say, this keyword or this.
No, I mean, typically, I don't know what this is, but they tend to be quite complex, and it's not like a term is necessarily in your profile, not in the profile. It's more on the weights. So the typical way you would do it in the traditional way, I guess it's more complex now with data mining and more data. But what we typically would do is that we would reduce a little bit a weight of the most important key for the videos you don't like. And if you like something, you will increase a little bit the weights of all the important tags or fields for the video you like. So over time, you will see a reduction of the ones that are common to the ones you don't like, and an increase in the weight of the other ones. But as I said, if you don't use it a lot, it's not representative, and then it doesn't make much of a difference.
So basically, if you just say I don't like this one, it doesn't mean that you automatically won't get those type of.
But if you do say, well, I think, but if you do say quite a lot of times I don't like this, and there is some commonality to all the ones you don't like, then it may actually have an impact. But that is where at least that's what happened historically, is that users didn't do that. They didn't give enough feedback for those feedback loops to really work. So.
Wait, didn't you talk last time about the paper that looked into like if people have too much control over this, they actually get worse recommended?
Yeah,
but
so
that was.
idea.
But in that case, they really got to edit the profile directly. But in this case, I mean, giving feedback is different because the feedback is handled by the system as, okay, you seem to have a slight dislike for something, and that is different from you actually being able to go into the profile and say, oh no, I remove this or add this, which is has much more of an impact.
That was kind of bad in my opinion, because if you just go into the heart of the recommended system and just remove stuff and edit stuff and without having acknowledging what is going on, of course you're gonna damage the system. It's not gonna work at some point. But as Runa said, it's more having a complex way of interacting with the system, like having interfaces that by using feedback, different type of feedback, you would adjust the recommendation process instead of just removing keywords or.
Okay, I think we need to move on.
Yeah. Yes, I'm doing web of things, and I'm looking in my paper, in my project. I'm trying to look into some problem areas within web of things, and my angle is a smart gateway and how I can use how it's able to use, for example, in a home, smart home, how I can use smart filtering, data filtering to improve or solve issues within security and privacy and stuff like that. But the problem is, for me right now, is that this is still a problem in the web thing. So it's kind of hard. When I set this this problem description, I kind of made a trap for myself, because I kind of have to know that there's an answer before I make my problem description. But now I don't have a solid answer, and I have a problem description. So I'm working on it, but it's kind of. I mean, there's a lot of papers out there that feel like kind of service, where they, since this area is like new and exciting and stuff like that, it's many people that introduce you to the web of things and the internet of things, and many of them they identify the problems and they tell about why these problems are there, but there's not many answers or solutions to them, or then they would be there in the first place. So that's kind of my challenge right now, and I'm not sure how much I should write state of the art about the web of things. How much I know that I should introduce the different aspects of sensors and APIs and stuff like that, but I'm not sure how much time or research I should do on it, or if I should be rather doing a survey on the possibilities of a smart gateway, or my angle, the specification of my problem description. I'm kind of in a problem right there.
I would think that for this paper, this course, I think what would be a good idea is to try to dive into the gateway and see what are the features a gateway support, general features, and see what's been done in those various areas to see what the status is. Because in this course, you're not supposed to come up with any new ideas or anything.
Supposed to be
but what you're supposed to do is to try to see where the field is at right now. And here, so if you look at the gateway, what are the main responsibilities of the gateway, and how
what's the state of the art within each of these, and what is the current research focusing on, and what are the unsolved problems, and what seem to be kind of a consensus and solved. So I think that would be the best approach for here. And then, taking that into account, you can look at for the advanced project work and for the master thesis, take one of those still open areas within the gateway and say, okay, now this is what I would like to look at. And then you can try to set up some case and some, okay, this is what I would like to try to see what we can do.
Okay, so I have about crawling the web. And my focus is on, of course, rich internet applications, like JavaScript, client-side executions, and then dynamic change of the DOM. I have about like 25 papers that I found, but it's like 12-ish that I'm kind of feeling like fits my area. But I discovered that 7 of them is actually of the same people, the same group of people. So it's IBM is a part of that kind of group. Is it really focusing on researching in that place? So yeah, it also have papers that are really talking about the same things, but there's the same people. It's so hard to find other people that uses the terminology in the same field. They also wrote a brief history about crawlers, and they separate what deep web is and the rich internet application is. So I have to kind of find some other papers that agrees with their point of view, uses their terminology, and so far I feel that that's the case though. And they like deep web, it's all about the information that is hidden behind forms, when like backend programming and PHP and all this came to be, and that's when these deep web crawlers came to be, trying to find information that it hides behind forms and in databases. But for now, the most like hot topics today is the rich internet applications, where you kind of want to find the client-side hidden web, where it's like the dynamic changes of the DOM with asynchronous calls with Ajax and stuff. Yeah. And I also kind of started writing some brief notes in my papers, and trying to find a link between them, which is quite easy when there's the same authors.
And it'll be terms of how the discussion about that. So how bad is it that all the work seems to be done by one group? And on one side, it kind of indicates that this is something a little bit obscure, a little bit on the side, because if it had been very hot, good topic, then we will see more groups to it. But it doesn't have to be. I mean, if you look at the web browsers, and SQL has never been standardized on a web browser, even though you have SQLite or SQLite. And the problem is, among other things, if you were to implement SQL or SQL on the browser, you will have to first decide which version of SQL, which is in its own right a tricky thing. But the other thing is that the web consortium, they would like to see a standard being implemented by more than one group. Now, SQLite is implemented already, and making a relational database system is quite a lot of work. So no one else will want to invest a lot of time to implement it a second time. So there will not be a second implementation. And without a second implementation, the web consortium would not approve it. So in the web case, the relational databases on the web browsers is not going to be, most likely not going to be standardized by the web consortium. And it's not because the work done by SQLite is bad. It's not because the standards will be bad, but because it's so resource intensive. And if you think about the crawling, it might be some of the same discussion here, is that if you as a researcher would go into crawling, it's
require quite a lot of work to get to where the state of the art is, according to this group. So unless you happen to be Google or some major player here, you may not be able to. And the Google and major players, they may rather solve the problem than tell the world about it. They may not. So again, the bottom line is that it's not, you can't just, by saying that you have a small group, you can't just say it's a good or bad thing. So you need to go into it and see that, okay, if the group and IBM, they have done quite a lot of good work in crawling and in databases and all of these areas. So if it's a good group and published in well-recognized channels, even though they're just the ones, it's probably because it's a very hard and complex thing, and no one really is, except for maybe the major search engines, no one finds the motivation to dive into it. So it's not, shouldn't exclude us from diving into it, but we need to, as you're saying, suggesting, we need to be a bit careful when some of the, when there are a lot of hot papers and just by one group, it's usually not the best side. But there might be good reasons for it. So for, like we talked about, for different sources as well. I mean, some conferences aren't well recognized. Doesn't mean that all papers on these conferences are bad, or I mean, we generally don't use blogs and just stuff we found on the internet. Doesn't mean that all information being published on a blog or is a bad quality. It just means that we have to use our extra critical sense in assessing how trustworthy is this, how much can we base our research on it. But we may not need to exclude it, even though it's not the preferred channel or the preferred setting. Okay.
Yeah, I have one question for you. Maybe have you looked more about this role in leveraging the knowledge of framework used to develop application?
No, but I tweeted the guy that has some responsibility with Angular, but he didn't know either, so he was interested in what I'm going to write about. So.
Good. Okay, so there is interest. Yeah.
What about, for example, like user accessibility tags, for example, because many, like Angular, they have lots of those things.
So that's kind of it. If you kind of create a crawler that fits Angular, then that's what you have. The thing is to have a crawler that can general purpose crawler. But so you have to look into how they generate the JavaScript and all that stuff. But yeah, I think that's an interesting area, because if you do that and see if that's a really beneficial in terms of speed and how you save all the states and stuff, it might be the right direction that all the standard web should have something like that. But I haven't found anything about this.
But it's definitely an interesting thought. I mean, the fact that some players get to be big means that you can do some special processing, and Angular is usually quite easy to find that this is Angular scripts. There are some ng dash something there, so it will be possible. So even though it's not a solution for a general case, if that special case is getting very common, then you can afford to do some special case development and do better on these type of pages than other types of pages. And as you said, that may indirectly mean that more people will start doing this. It's like the all the semantic tagging. If no one's adding semantic tags, then nothing much happening. But as soon as you see microformats and other type of tag systems being used by quite a lot, then if you are not tagging your content, it won't show up on the top of the browsers, and you have the problem, and then you start using it. So it's a little bit the same we can think here.
And if you target those three frameworks, maybe it will be big enough.
Exactly.
Area covered.
Which means that the new framework would adopt some of those mechanisms, as you're saying. Yeah.
Another challenge there is that Angular, I'm not sure about too, but I will assume that you can create your own attributes, your own elements, and all this stuff. And then how do you detect clickable elements? When some of the research have done, they basically just said that oh, you should look into the A tag, the button tag. You should just, those tags are candidate tags or elements for being clickable. But when users and developers can create their own tags, then it's kind of difficult.
But again, I mean, this is a kind of a moving target. Now, we have the hidden web, and nothing is being indexed on the hidden web. If you can index 85% of the hidden web using these mechanisms, okay, there's still 15-20% that you can't index, but at least you have indexed 85%, which is already much better than the web was. So it's kind of a moving target, and you will never get 100%.
Yeah.
I was thinking that interesting way to solve this issue could be, because I see that some frameworks now tend to recommend developers to specify the state of their application they have, and by specifying some kind of model of the data they have, and in which states of your application can be. And by specifying that, you actually give a tool for this kind of technology to access your application. You just go through all possible, generate random state based on specification given by developers, and you index your web application. So if this movement will rise in the future, it could be a way to index web application, as far as I can imagine, at least. You don't have to even click the buttons. You just trigger the state that application then use. So that can be a solution, I think. But yeah, my topic is demand-driven architecture, and currently I'm reading more about it and trying to make some notes. The more I read, the more it looks like a natural development going from REST API to this demand-driven APIs. It looks like because REST was developed to make flexible APIs, to make decoupling and stuff like this, and now this API addresses the same issues, but makes it even more flexible, even more decoupled and stuff like this. With rise of that, also can be connected with rise of Internet of Things, because having additional devices will require additional APIs and points for REST API, or quite a lot of redundancy. In other case, if you will reuse APIs defined previously. So demand-driven architecture suits very much, in a very good way for things like watches and Internet of Things or mobile clients. The challenges in this area that I can see, at least for now, is efficient backend server. When I dig into this area, I see that initial implementations of backend sites are inefficient, and in the terms that they do much more work that they could do in other case, meaning that, for example, having query or API that allows you to have your favorite movies and recently added movies or something like that, and when you ask for both of these things and one movie occurs in both lists, in current implementations, most of the implementations will do 2 queries to database to get the same movie and the same data, which is not efficient at all, especially on the big scale. Recently, Facebook released their solution to this problem, which is called Data Loader, which solved this problem by introducing caching and batching of the queries, which is kind of fighting with consequences instead of making efficient queries and build efficient queries based on the query given from the client side. They kind of
do inefficient queries, but just cache the results or batch queries. And it solves problem partially, at least the worst part of it. However, it doesn't solve the problem when, let's say we have, again, this recommended movies and recently added movies, and we have one movie in each of them. But, for example, in one place, we request two, like, movie name and movie rating. In another list, we request movie description and actors. So, and let's say, and also name and rating the second one. So instead of making one query that will request all needed fields and then propagate these fields on the needed lists, it will again make two queries with each of them will have each like set of fields. So, or in current implementations, they will even get all fields that movie have, and then will kind of cut the unnecessary stuff, which is also not efficient. There is one development in this area that tries to solve the problem by making efficient queries. However, it kind of put more work on developers, as usually. Then you have to create two-level graphs instead of one. In first level graph, you define low-level data sources with just raw data from your data sources, and then second layer graph is more like API, which, for example, combines data from first level into something more that's suitable for clients. Like, for example, you want URL of some product. You don't usually store URL inside the database. You generate URL based on some fields. So second layer graph requests, for example, product ID, product name to generate, and then generates URL based on this data. And this first level graph can have different access to different databases. So this solution solves partially problem, introducing new problem of making two-level graph and stuff like this. Another issue with the backend side is that most of the solutions, they don't usually care much about when your fields that you want to give to your clients are hard, are so complex that you need to make several requests to generate this field. A good example of that can be product price on Amazon. To generate product price you show to users, you have to know product price, which is just field in the database, but you also have to know current discounts on these products, current currency rates. You want to know currency rate of the user, currency rate of the product, and a bunch of other things that can influence the price of the product. And making requests for each product in the list of 100 products, for example, will just kill your database, especially on the big scale. So these kind of issues, I don't see, at least, that they have been addressed much. Maybe they will be, because it's kind of emerging now slowly, this technology. It's just 1 year, so we can't expect much of it. So for now, I kind of see the most challenges are on backend side. Client side looks pretty kind of good and clean, requesting only what it needs and renders. But the backend side should be improved a lot.
And mostly in terms of performance.
Performance, yeah, mostly in terms of performance. And security, of course, as well, which is also planned to dive into how security problems are solved in these systems.
Okay, so I hope we got kind of to see that from the core, there is more happening in depth here in all the projects. That's the way we should do it. Since this is the last time we were gathered here before you submitted the reports and we had examined any questions, any concerns.
What is the last day you be able to review papers?
I'm probably not going to be here Friday afternoon, so I have to be.
So if I send you email on Thursday, would I then it's late?
If you all send me 20 pages to read on Thursday, I won't be able to do it.
Okay.
Yeah. If one does, I will be able to do it. So it's this. I mean, I'm a limited resource. So the sooner you send something, the more likely it is I will be able to. It doesn't mean that I won't be able to, but it depends on the total amount of requests, not so much on me.
Should we have abstracts in the report?
Yes, I think so. All reports should have an abstract. And I'll send you, as I promised in the beginning here, I'll send you that short scrutiny of the abstract, which tells about what the abstract should be. Because I've been for a long time I was having the 4th seminar in the research project planning, talking about the report and the project planning. I've been doing that for 2 years. But what I always did then is to go through the report and say that the abstract is probably the most important part of any paper.
Yeah.
Because abstract is besides the title, abstract is what everybody reads. Now, based on the abstract, they will decide whether this makes sense to go on further.
Yeah.
So I think the way I read is I read the abstract. If I like the abstract, I go to the conclusion. If I like that, and the introduction and conclusion. If I like that, I read the middle part. The middle part is the least interesting. And so if the abstract is bad, it won't have the right readers come to read the rest of your paper. So so what you should think of is the abstract. Maybe I'll do this. So you have your intro, you have your methodology, you have your results, you have your discussion, you have your conclusion. Now, in the abstract, you should summarize the most important findings, and they tend to be mostly here. So the abstract should be a short summary of the conclusion, but to be able to do that, you need to have a short intro or maybe introduction, maybe if there's something special with the methodology, not so much the results per se, but you may have small pieces from here, but mostly from here. So the abstracts I've been reading that I really think miss the ground are the abstracts who introduce the introduction. So it's all about what I'm planning to do and why this is important to do. What you want to do is what you want to know is what you found. What is really the important stuff here? What can you tell? And for that, you start with the conclusion, and you may have a small part of the introduction, a small part of the methodology, so that you can understand the conclusion. But it's mostly should be a short summary of your major points that you conclude. But that should be the abstract.
Should you, like, if you have some interesting things in discussion that doesn't?
Yeah, you can. But that will typically, that part of the discussion will typically influence the conclusion. So yeah, absolutely. I mean, if there's interesting things here, but that will typically be covered because that will lead up to some conclusion. So start by saying, okay, now if I were to summarize what I learned in the best way, that's what the abstract should be.
In terms of the structure, intro, methodology, result, and discussion, is it allowed to like have different titles in terms of like what I think it's important?
Absolutely, yeah. I mean, and there's, if you ask me what is the right structure, I can tell you. I mean,
yeah.
For instance, if you, and that's more the case for a larger report. But let's say that Gregor's project has 2 parts. So it has payment frameworks and it has Bitcoin. So that will be in the results. You will have 2.
in the discussion, you will have something related to payment framework, something to Bitcoin. And then in the conclusion, there will be one part in the payment framework and one part in Bitcoin. Now, would this mean that there should be one methodology, maybe the methodology for answering these will be different. Now, should there be one methodology section for payment framework, one for Bitcoin? Should there be result be one for payment for Bitcoin? Or should it be one Bitcoin with methodology, result, discussion, and then payment system, payment framework, methodology, research, or results, and discussion? Which is right? And I couldn't tell. Because it's about, as an object-oriented design, it's about coupling. Because within a chapter, you would like to have tight coupling and loose coupling between chapters. So if these two projects are so separate that there's almost nothing to discuss about payment frameworks in here, then this will be a favored. Because then most of the references here are very local. So you refer to the previous section or the next section, but you don't do long jumps if you want. Now, if most is common, and there are some small variations and varieties, then obviously you describe your methodology and you say, oh, but for Bitcoin we did a little bit different. And you say results, and you can summarize, then this would be the preferred, because then you have local references here and very few long jumps in between. But you can't, because this will be all project dependent, and you don't have to have these titles. This is more the conceptual idea that because what you don't want to do is you don't want to have a discussion when you talk about methodology or results, because you would like your results to be open for others to study. And if you mix up the discussion with the results, it will be hard to say what are the results that you found and how do you interpret them. So that's why you say, okay, these are the results, and you can aggregate, because otherwise it's going to be too much. But this is the discussion. So we can say, okay, these were results, and this is how you interpret. So somebody else could take the same results and do their own discussion and analysis and see if they come up to the same conclusions. If it's all mixed up, you couldn't tell what is really your understanding of data and what are the real data. So it's that's why you like to say, okay, this is how we set it up. This is what we found. This is how we interpret it. This is what we conclude. It doesn't matter. I mean, you can put it all within one chapter about each of the subtopics. You could do it in sequence as a top-level chapter. That doesn't matter. That's more how you communicate it in the best way, so the reader has an easier job understanding what you did. But the important thing is that you kind of separate these discussions, so it's clear how do you set it up, what did you find, how do you interpret that, and what do you conclude based on that. That should be clearly identified, whether it's in a different chapter, whether the chapters are, or there's sections in the chapter, or what it is, doesn't matter. That's more what works to communicate what we did and what we learned.
So in the discussion chapter, we should have more or less our own reflections.
The discussion is where that's right, the discussion is, so in the results, this is where you review the paper. So there should be a paper review section, and there you summarize what they say and how they present this and what they contribute, and you group that into your understanding of how things are related. In the discussion, you start to analyze, you start to compare the various ones and how you interpret what they did and how you see what they did compared to what others did. And then, based on that, you conclude. Yeah. But this discussion shouldn't be so much about what you believe in and disbelieve in and what you think about the future. I mean, it should be how you think they relate, how you think. So that's kind of your contribution base, because otherwise when the papers stand by themselves and they have presented what they believe they contribute. Now you will have to have a larger picture, say these guys relative to the other guys, how do they contribute and how do they match up and where they disagree and why do they disagree and things.
Do you think some of the 7 papers with the same authors agreeing with every 7 papers? Or
Not always, because sometimes there's a progress. I mean, in my own PhD, in later papers, I had obviously extended some of the initial ideas, and some of them improved, and some of them were just thrown away, and that's quite normal because there is a timeline here, and you learn more, and
You have to go back as well. And not all of that is clearly stated. So sometimes you will see that they discuss something in the early papers and don't do that, and then say, well, how come they didn't pursue that any further? And then if they don't say anything about it, you can say, but you can at least identify, say they started out doing something and then they changed direction and they don't discuss why.
So discussions shouldn't include much of our own impressions, but has to have more like a summary of similarities and disagreements between the papers based on facts, or it has to be like our own impressions. And well, because once you said that it has to be repeated, the discussion could be kind of the possibility to be repeated from another one.
Yeah, so they should be able to interpret, and they may come to a different interpretation. And in that case, it should be possible to discuss. And if you say I believe, and you don't say why you believe it, so that's why you need to root the discussion in the results. So if you say, I believe this is stronger, and then someone else says, I believe that is stronger, then you can't really discuss. But if you say, I believe it's stronger because these and these and these things are important, and these other factors in the way you understand the world, and you can refer to other papers, that these questions aren't as important. And then somebody else says they have the same, they value the same way, but they come to different conclusions, then you can really say, okay, why do they come to different conclusions when they don't put the same weights? But if you see that they put the weight on something else, then you say, okay, clearly disagree, because you think it's more important to have user-friendliness, and I think it's more important to have security high, and then it's clear why you disagree. So, but that's why the discussion needs to be rooted in the results, and not just taking out, oh, I believe that this is the way to go forward. That's not scientific, and it's not something that you can really set up for a discussion. But you can say that, okay, I can see that this has happened. These are the steps that I'm seeing, and I see that there's something missing here, and it's similar here, so you can expect the same steps. Then at least you have a reasoning for concluding or for stating something, and that's the reasoning behind demonstrates how well you understand the topics of discussion. But it's not just a discussion paper. It's more trying to analyze and say, what can we learn from looking at what's done in the field? How can we understand where the field is at? So it's not just a free discussion of whether you think microservices is the way to go or not. That's not the purpose here. It's more, as you were saying, okay, microservices, there are certain apps, and especially I would think that especially apps in which there's a tight coupling between the various parts. It's impractical to separate the services, because then you need to start shipping all the context that all the services should share, and start to ship it and encode it, and they are very context dependent, which means that they aren't as stateless, and it gets quite complex, and that may not be very well suited for microservices. So that kind of analysis is very valuable. Whether microservices is the way to go or not, that's unless you can have the clear arguments why is it the way to go, and in what cases is it not the way to go, based on your understanding of the strengths and the weaknesses of technologies and what's been done. Okay, so it's when I look at any laws or any legal system or any contract to sign, I'm more interested in trying to understand the intention or the intent of the wording of the laws than the actual wording. So the same here. It's not that if you have a chapter methodology, you're fine, or if you don't have a chapter methodology, then you're not fine. That's not the thing here. The thing is it possible for a reader to understand what you did, so they can see if they can find the same thing if they did the same, went in the same area. Given the same papers, I don't mind whether there's a discussion chapter or not. That's not the important thing. The important thing is that there is a discussion that is clearly identified, and that you can clearly see that this is how you read it. And if I read the same papers, I should be able to have a similar discussion. And if I conclude something different, then we should find the cause of the disagreement. So that is the intent. So it's not so much about whether you have the right keywords here and there and right terms and right chapter structure. That's not so interesting. What is relevant is that you can actually answer, or in the area you are trying to draw the picture, where is state of the art in this area, and that means that you need to give us enough understanding of how you found these papers and what these papers describe collectively, and how we can understand the field based on these papers. That needs to be there. What the chapters are, and how what the names of the chapters are. It's not so important. It's really what the content gives us.
If I write a paragraph about the papers I've chosen and kind of explain why I've chosen those, where should that go? Should it
That will be here in the methodology. Whether you have a separate methodology chapter or it's part of the introduction. I mean, often you could say the introduction is you introduce the field, and then you summarize the problem, and then you say, okay, this is how I went forward to do it. So you have a small section on your approach or methodology. That's fine, because in larger works where you have a more complex methodology, you may have a larger methodology section. But as we're saying, Gray was asking, you may not even have it if it's pretty clear that you went to the databases and you use some keywords. There's nothing you need to say about it. So it's all dependent on whether it's easy to understand how you went forward and whether what you found is something that is really representative to the field. That's why I think it is a good idea to say, okay, I looked at these journals and these databases and these keywords, because then it's really stated. If it's not, if it's clear that what you cover is good, then there won't be any questions. Now, if there are questions, the question is, what would that mean to the report? So it's good to be explicit about it. Then you're sure that the reader will know. Okay. If you have any other questions or concerns, you just drop by my office or send me an email.
Do you still have time to talk to me?
I